Okay, so this is problem number 2 on the Physics 2048 Fall 2014 exam, and the problem reads, an object is released from rest at t equals 0 near the surface of an unknown planet, not Earth. It falls 10 meters during the time interval from t equals 0 to t equals 2. T equals 0 seconds to t equals 2 seconds. Ignoring atmospheric resistance, how far does it fall in meters during the time interval from t equals 2 seconds to t equals 3 seconds? So right away, straight off the bat, we know that the acceleration of gravity in this planet is not 9.8. We know that because we're told it's not Earth. So I think we need to figure out the acceleration on this planet. And the way we're going to do that is we're going to use a kinematic. And in this case, I think the most appropriate one is going to be d equals bit plus 1/2 at squared. So now, before that, let's set up what we know. We know that the initial distance traveled between between the beginning where it's thrown out and when we measure this distance is 2 seconds. So in 2 seconds, the object has traveled 10 meters. The object has traveled 10 meters. So we write that right here. D equals 10 meters. So what we're going to do here is we are going to plug that value in along with the time. We know we have the time and we have distance traveled. So then 10 equals 1/2 at squared. What happened to the VIT, you are wondering? Well, VI is 0 because the object is initially at rest. So that goes away. It simplifies the equation even further. So D equals 1/2 at squared. After that, we plug in 10, and we are going to plug in our time, which is 2 for this particular part of the problem. So 10 equals 1/2 a 2 squared. So at that point, we're just going to do a little algebra. I think we can handle that, and that simplifies to 10 equals 2a. After that, we just solve for a, and we find that the acceleration of gravity on this planet is 5 meters per second squared. Now, we need to use this kinematic again, but this time we're going to account for just 1 second between 3 and 2. So we're gonna do that by also finding out what the velocity is initially. We know now that the initial velocity is no longer 0. The object is moving. So how do we figure that out? Well, if we have the acceleration, we know that the acceleration is a derivative of velocity. So if we were to integrate 5, we could find what the velocity is. So if you integrate 5, you're going to get 5t. And we know that at that given moment, time has 2 seconds have passed. So we plug in 2, and we multiply by 5, and we get that after 2 seconds, the velocity of the object is 10 meters per second. So now we have that. We have a new VI. We're going to use it. So we have the new displacement, a new displacement that we're trying to find, which is the one between 2 and 3. So D2 equals VIT plus 1/2 at squared, and we know right straight off the bat that VI equals 10. We find that here, and then we know that t equals 1 because that's the total time passed between 2 and 3, plus 1/2 5, which is the acceleration we find, which is a constant acceleration, times 1 squared. And at that point, all we got to do is just the arithmetic here, and that simplifies to 10 plus 5/2, which is also equal to 12.5, and that is the total displacement between t equals 2 and t equals 3 seconds.